here are the examples from 11.2. We're going to be talking about sectors and then central angles and exterior angles in a circle. So, first question. The radius of a circle is 10 miles. What's the area of the sector bound by a 90-degree arc? All right. Area of a sector. All right. We're going to need that formula, which is x over 360 times, oh no, not 2 pi r, I'm sorry. It's going to be times pi r squared. Boom. Always take your time to make sure you're working with the right formula. And then we have our central angle up top and our radius down here. There's our radius, there's our central angle. Let's substitute those numbers into the equation. And we have 90 over 360 times pi times 10 squared. And if we put this in our calculator, we know 90 over 360 is 1/4 times 100 pi, and that's going to be reduced to 25 pi. Boom. And there's your answer right there. 25 pi. Now, if I was doing this in the calculator, I just would not put the pi into the calculator, okay, guys? So if you're kind of like, man, I don't know how to do it without the pi, well, you know what, just solve for the numbers and then put the pi on at the very end. Diameter is 6 miles. What's the area of the sector bound by a 150-degree arc? So we have our arc length, that's our x, times pi r. What's my r? Is it 6? No, I want my radius, and my radius is going to be half of 6, which is 3. Cool. And here, we're going to just reduce. I'm going to put that 150, oh man. Okay, if I reduce this guy real quick, I know this becomes a 9. This guy's going to become 15 over 36. I can cancel the zeros on those guys, and then 15 over 36. If I divide by 3, it'd be like 5 over 12. That might be as far as I can get. Now I have 5/12 times 9 pi. Can I reduce a little bit more? Again, if I put this on my calculator, I'll be able to get the answer smoother. I'm going to do classic algebra, or classic cross-reducing. So 15/4 times pi, or 15 pi over 4. I'm just not sure which one IXL would take. Probably this one. And if you wanted to do it as a decimal, it'd be 3.75 pi. Any of those guys should work, in my opinion. I mean, they're both correct. It's just a matter of what IXL will take. Some other problems you're going to see have to do with the fact that there are how many degrees in a circle? 360. If any of you guys have done things like skateboarding, swim and dive, basketball, anything where there's a 360-degree rotation, it means, hey, you're back where you started. And you could even remember that back from chapter 4. You know, we did that, or not chapter 4, I'm sorry, but we did it back in first semester. There's 360 degrees in one complete rotation. So these guys are going to add up to 360. Well, if we know that, we're basically finding this leftover angle. We have a 70 and a 145. Let's add those together. 215. And then we're going to go 360 minus 215. And we get, I think, 145. Boom, baby. There we go. 145 degrees left over. Okay. And that concept, we use that same concept for guys, or for problems that have the angles on the outside as well. You know all the angles are going to still add up to 360. So we're going to go, okay, well, we got a 104, a 60, and a 53. Let's do our old school addition. It's been a while since I did this. 217. Now I'm going to go 360 and subtract 217. I'll zoom out of here so you can see better. 143. Bop, there we go. So, there's the examples. Please let me know if you have any questions. Thanks for watching. Have a good day.